and thank you for being here today. I am pleased to guide you through this session today about green hydrogen innovation, concrete steps toward Europe's energy transition. I got some water here, so please feel free to get if you want it. I would avoid to close the doors because it's a bit warm, but if it will be too noisy, we can do it. So today we have a very exciting program and with excellent speakers here. Thank you for joining us. The workshop will be organized in this way. We will have 5 presentations about different projects. The presentation will be for around 10 minutes, and then we will have questions, share ideas, inputs, so please feel free to participate as much as possible. I will introduce you now the speakers of today. So I start from myself. I am Mariangela Vespa. I am a research psychologist working at ITSES, a research institute in Germany, and I am in the environmental psychology department. We study the social acceptance of renewable energy technologies. Then we are very glad today to have here Pietro Caloprisco, project officer from the Clean Hydrogen Partnership, who will take part in the workshop by giving the opening and the closing remarks. Then we have Guilherme Gaspar, lead researcher at HiLab, Green Hydrogen Collaborative Laboratory. Søren Karstens, technical project manager at Hydrogen Valley, Denmark. Patrick Witte, general manager at GPSS in Luxembourg. Konstantinos Chatsifotis, EU affairs manager at Motor Oil Group. And last but not least, Philip Fish, CTO at GPSS in Luxembourg. So the presentations will have 3 main parts. The first one will be the speakers will provide us with a project overview. Then they will show the key components and the findings. And in the end, we will talk about impacts, challenges, and next steps. We are live, and I'm here in order to coordinate also eventual questions from the chat. So I would like now to start and lending the floor to our first speaker, Pietro Caloprisco, who will give us an overview of the importance of hydrogen valleys for achieving Europe's climate and energy goals and the strategic role of the initiatives represented here today. Thank you.
Thank you very much. For the slides, how do we do?
Yes, this one.
All right, perfect. All right, so you cut me when I tend to speak slow, so.
Okay.
Well, good afternoon, everybody. So it's good to see you. My name is Pietro Caloprisco. I'm a project officer at the Clean Hydrogen Joint Undertaking. And for my presentation, I wanted to give you a little bit of an overview of what's happening in Europe, what's happening upstream, before we hear from actually what's happening on the ground with implementation of the different hydrogen valley. So I heard that even the speakers that are working for the projects are not so much in contact with the joint undertaking. So allow me with a couple of slides to just remind you what is the joint undertaking, what is our mission. So, sorry, this thing is changing itself. Okay. So first of all, we are a public-private partnership where the public sector is represented by the European Commission. Different DGs are involved, the DPN, RTD, and MOVE. And then there is the private side, which is represented by the industry and the research communities. These are 2 European organizations that organize this representation, and they're part of our governance. Other interesting elements to mention here that we'll come back to that later on is the budget that we've been assigned. It's 1 billion euros. This is for the period 2021-2027, and it's coming from Horizon Europe, the Framework Research Program, but it's purely dedicated to hydrogen and fuel cell technologies, right? And then in addition to that, we received an additional 200 million for hydrogen valleys, and I'll say a bit more about that later on. what do we do? Normally, that's our mission. This is the third joint undertaking, and our purpose is to support the development and the deployment of all the different components, pieces of the puzzle of the technology. So we're going from the production of hydrogen, the transport, storage of hydrogen, to all the different uses in transport or industry, and so on. And on top of that, as you can see, recently we have added this additional box, which is the Hydrogen Valley, which was not something we were quite familiar with. So how did we get there? Well, it's the issue of the valley. It's something we've been working for quite a while, since 2016. We're talking now about what, like 9 years ago? So as you can imagine, back in the days, the technology was still immature. It was very expensive. The performance was not great. So the real life applications were somewhat limited. So a lot of our job working with the regions was about explaining to people how they could feature this technology into their decarbonization plans, their local decarbonization plan, sorry. So it was a lot of explaining, working on early business cases, seeing the TCO, how the technology could deliver. Time goes on, technology progressing, we start to see also some industrialization in Europe, and the Commission, the European Union, start to take notice of our technology. So this is not something for tomorrow anymore. This is something that can be featured in the European Union decarbonization plans and ambitions. So in 2020, you see we have the European Hydrogen Strategy. Then in 2022, there was the Repower communication. Probably heard about that one. This was about, when there was the Russia invaded Ukraine, we realized that we are pretty much exposed when it comes to energy security. So there was an overhaul of our ambition. And as part of that, we also received 200 million as the joint undertaking, which are dedicated to the support of hydrogen valleys. So 1 billion is for hydrogen technologies in general, 200 million is dedicated to hydrogen valleys alone. And following that, we have yet another communication from the Commission where they were laying out their ambition when it comes to the deployment of hydrogen valleys. So as you can see, it took quite a long time. We started to talk really about how we could deploy this technology in the decarbonization plans. The concept of hydrogen valleys was starting to take shape. Technology advances, political pressure, attention, let's say, and that's where we are today. Sorry, wrong button. There we go. Okay, so, sorry. Okay, so 200 millions, what we've been doing with these 200 millions? Well, we started to provide grants to support hydrogen valleys, and this is where we stand today. There are 21 valleys, and there are some of them here, we'll hear more from them, that are being implemented, and it's quite nice to see here, to see how these valleys are the beginning of something bigger. There is a very nice geographic spread, but didn't happen by design. It wasn't us that decided where the valleys are going. We just awarded the best valley, and this is the end result. It's nice to see how it's like mushrooms, but organically they're coming up, and one day there will be potential to really create strong connection throughout Europe. The potential of all of these valleys, if you combine it, it's 30,000 tons of hydrogen produced per year and around 300 megawatt of electrolyzer capacity deployed. And on top of that, there is tens of vehicles and HRS. Of course, I'm talking about potential. These are the grant agreement that we have signed. It's a relatively young portfolio of projects. We're still far from those numbers, right? But that's the ambition, that's where we are aiming at, and there's no reason to believe that we can complete that or get very close to. Okay, so I'm getting the wrong button, there we go. But getting there is not going to be easy, and we will hear probably about it even later. Again, it's a young portfolio, so even a joint undertaking, we are still trying to get our head around it. But there are some common challenges that are starting to emerge that are clear. So the business case, it's not easy, especially now, that when it comes to hydrogen, the industry is in a tough spot. And we are seeing that increased cost of hydrogen, higher TCO, difficult for business models. And also when it comes to mobility, for example, there is a lack of variety of vehicles that can be deployed. So sometimes we see even there is a demand from a valley, but then there is not an industrial answer to that. That's linked to the second point. So there is a certain fragility of the supplier, the end-use solutions. Of course, technical challenges. These are a first of a kind type of projects. So it's not anymore about deploying one piece of the puzzle, the electrolyzer, the HRS, the buses, and see how they work. This is about putting them all together. This is making them work in sync, right? And then there is also the issue of additional funds. We are publishing calls for a small valley, 9 million and 20 million for the large ones. Well, it's a lot of money, but still it's peanuts. If you look at the overall cost of the hydrogen valley, sometimes we represent nearly 10% of what is actually needed or what are the costs. So additional funds needs to be mobilized at regional or national level. Not always are available, not always match in terms of timing. Regulatory framework. Sometimes there is the technology, there is the idea, but there is not a regulatory framework that allows to create a business case. So, for example, you cannot connect directly some of the fuel cells to the grid for grid balancing purposes and getting rewarded for that. And then, last but not least, we are also realizing that without a strong leadership of these projects, it's quite tricky to go ahead. You need to have a vision, you need to have a very, very strong leadership to make sure that all the consortium goes along at the same speed. At the same time, it's not all doom and gloom. Things are progressing, we are advancing. We see that there is a lot of the different assets that have been procured, designed, civil works. So we are quite confident in the next couple of years we will see things being deployed on the ground. And some of the valleys are also being successful in leveraging national funds. And all in all, there is also a lot of learning that is being created on how to manage this type of projects. Throughout this time, we have been providing our support. We will keep on providing support. Our primary weapon, let's call it, is the grants. So this is where we directly are supporting the hydrogen valleys. We are continuing to support the R&I for all the technologies. More durable technology, cheaper technology will make it easier for anybody that wants to create a hydrogen valley. We are also insisting a lot on the creation of a European added value, so local assets produced so that there can be also aftermarket services. And we are trying also to coordinate as much as we can with national and regional authorities. And last thing I want to mention, we are also creating, so these are the grants. You have an idea for a project, you come to us, submit your proposal, you win it, and you start to implement the valley. And then there is another type of service which we are providing, which is called the PDA, the Project Development Assistance. And well, I will mention it very rapidly, but take note, if you're thinking about doing a hydrogen valley, or even if you have one, this could be quite interesting. How it works. We, the joint undertaking, selected a consultant. We gave them 12 million and a half and said, okay, your mission now is to go out there and help those that want to start a hydrogen valleys, right? So you may have the beginning of an idea, which is not too immature, but you're not ready yet to go for innovation funds or a grant or what have you. You still need to do the final bits and pieces of the work before you are really ready to go. And that's what the PDA is for. Basically, these are consultancy services. You apply to those. They will make a selection of all the different ideas. And then they will help you through 2 separate services. I don't have the time to go into the details, to mature your idea and get closer to the time when your idea can really become a viable project. Voila. And sorry, that was very fast, but 10 minutes. And it's just an overview of what we are doing there. All right?
Thank you so much. So thank you very much for this overview. And it's really important to talk about the challenges, but it's even more important to talk about the progress made. That's why we are here today, for knowing more about these interesting projects. If we have very quick questions for Pietro, maybe we can ask now or we continue with the other presentations. Okay, so we will start now with Guilherme Gaspar. So please welcome our speaker who will present HU Talent, Alentejo, Green Hydrogen Valley.
Can I do the rest?
It's yours.
So, yeah. So, good afternoon, everybody. So, I'm Guilherme Gaspar, so lead researcher at Lab in Portugal. We are here representing a consortium of 29 partners at the HU Talent project. So, it's a large consortium, which is always not easy to handle, but we have a know-how there that will be very important for us to make it work. So, it's all the way, yes, opposite. So, a brief summary of this. So, the idea is to implement infrastructure at the Alentejo region. So, Alentejo is, let's say, a very large region in Portugal, is in the southern area of Portugal, where there is already a strong penetration of hydrogen, especially in the petrochemical industry. So, the idea is that we take advantage of what exists already and try to build on top of that. So, as a main target, we want to produce 500 tons of green hydrogen there, and that this 500 tons of hydrogen is not only for one purpose, it's for multiple purposes. So, and which includes industry, mobility, and building applications. So this is seen. So Alentejo. So we are based in Sines. So production is based in Sines, and Sines has also a very important deep water port there, which is already very mature on export and import of goods. So we also want to, enhance this infrastructure already existing. So it's a large consortium. It's we have Portugal, Spain, Luxembourg, Germany, UK, Brazil, and Morocco. So it spans not only across Europe, but it's also outside. So it's actually a very important asset by itself. So we should be able to help others to develop, but we also are supporting our, let's say, development on the Luxembourg Valley. So present here. And at the end, we are a consortium of 29 partners and 7 countries. So this is basically the overview of the team. So it spans from academia to industry and also municipalities, which are very important in this project as well. So this actually is a valley actually led by University of Everett, which is also in the Alentejo region. So this is basically the structure of the project. So this is the map of continental area of Portugal. So it's basically 4 locations. So one in Sines, as I already mentioned, so where you have the production. Then we have Évora and Alandual as the end users, and we also have a third end user, which is actually more energy community at the very south of Portugal. It's not in the Alentejo region, but when the project was submitted, we thought that we could be a good asset to add because it's a very different asset for a valley. So it's basically a small valley, of course. So in Sines, we have right now we have a production of 15 megawatts of green hydrogen planned. It's not there yet. So the idea is that we inject most of these 500 tons per year in a hydrogen backbone that is also being developed and there. And we have Galp, which is the largest petrochemical industry in Portugal, also with an important role of intake and offtake of hydrogen from the backbone. So and on the right-hand side, so we have a collateral island, so working by itself and with little interaction with the other assets. And then we have Alandual with the mobility case study where we have a bus and a garbage truck, so which should be fed by 2 trailers from Sines, together with a municipality pool where we have a system for hot water to feed the municipality, especially in winter time. So this is basically our assets there, which looks simple, but you will see it's in reality it's a bit more complicated than that. So this is the structure of the project. So the core of the project is actually based on the work package 3 and 4. So where the assets should be developed. So work package 3 is the production and injection at the backbone, and in Sinus, the work package 4 is more the end-use applications from industry to buildings. And then you have all the other work packages supporting it, such as the creation of digital tools for management, upskillings and replication guidelines, and then all the other work packages that are more dedicated to exploitation project management. So this is our, let's say, timeline. So just basically to that, we have started a year and a half ago. So, and we are about 1/3 of the project. So up to now, things are going okay, but once we start to enter the phase of implementation and engineering and construction, then it's actually on the right-hand side of this dashed line. So we are going to face like a, let's say, a challenging time for the project, which is good in many cases and here as well, for sure. So in terms of progress, so up to now we have delivered 11 deliverables, so it's about 30% already. So 2 milestones achieved. So I want to highlight the milestone 2, which is engineering design for the project. So we have accomplished that. So we know what we want and we know what we are capable of, but we are pending some issues. I will bring you on to you in the later slides. In terms of collaborations, we have a robust communication among the partners. 29 parts is not easy to handle, but we are working on this to make it. So in terms of demonstrators, because I think that's what where the core is about. So we have the production of hydrogen in Sinus as part of work package 3. It's an industrial area, so where we have land available, where we have petrochemical and chemical industry, we have GAP, and we have Repsol polymers there as well. So all of them needing, let's say, hydrogen. So we are in the phase of, let's say, we are kind of in engineering design. So the final investment is still pending because it's supported on public funding. So it's supported on the Portuguese resilience plan, part of it. And so this means that we have to wait until until the local government gives a step forward and help us to approve it in due time. So we have to be producing green hydrogen at an average of 500 tons per year at the beginning of 2027. So this means that we don't have a long time to go, but we are working with our local government to make it happen. There is a particular case here is that we need a 2-trailer filling station there at this stage because, as it was mentioned in the previous presentation, the idea is not to work individual assets. We want to work individual assets, but then we have to bring them together. And that will be a very important asset there, this 2-trailer filling, because then it connects production to the end use. And it's not partially there yet. Okay, it was at the beginning, but then as partners moved around a little bit, then we are still looking for extra budget to cover this part. So in terms of mobility, we are targeting a fuel cell bus and a fuel cell waste collection truck. So these will be the main assets. The other one will be a refueling station. It's built by PRF. It's a company dedicated to building these kind of assets. So they are partners in the project. And so they will install it there. So we already have an interesting place. It's close to a municipality warehouse. So this land belongs to the municipality. So relatively easy to work there. So we have also power supply at the scale we need. And so this part is going relatively smooth. And we are starting the tender for the first bus to come. In terms of the swimming pool at Évora, it looks a bit more, it's a bit trickier here, because at the beginning of the project, we had a company called Fusion Fuel, so they were attempting to implement 1 megawatt at Évora, so locally. The idea was also to develop a backbone there, like a small-scale backbone in Évora, which never happened. And so which means that the production of green hydrogen in Évora and the backbone never happen, and it won't happen in next years. So this means that we have to sort out in a different way. So together also with the project officer, so we try to attempt something different, which was a local blending system to reach the target of 20% of hydrogen in a blend with natural gas. So the idea is that we get it from the local distributor, then we redirect the pipeline towards this blending system with storage of hydrogen, and then we bring it together to the combustion system to work with the 20% of hydrogen. So, but here there is a concern, or main concern is that our local legislation, they don't cover hydrogen in public spaces. What it does is that there is a big umbrella to work on explosive and flammable gases, and then that's it. Okay, and this poses an issue when it comes to public areas, because then public areas you cannot control the number of people that are around. Most of them don't know that there is an hydrogen there, and we have a safety issue there, which is also the municipality is also concerned about. So the idea here is that we bring, let's say, this facility for the blending far away from the let's say where the swimming pool is and where there is a circulation of people, and then we have to work from there. So it poses a question, because if it gets too far away, we have a long pipeline, and if there is a long pipeline, there is a large investment, and the project at this stage for what has been designed doesn't cover it totally. So we also have to look for extra funding from local authorities or entities. So that's one of the other concerns we have there. So I bring also the positive points, but also want to raise the challenges, because that's what preventing is this technology and this economy to grow. So regarding Collateral Island, so it was already let's say energy community implemented, so they have the stamp of energy community already. So we are just adding like a containerized system that produces hydrogen locally, and we can use a fuel cell there to power the grid, so the local grid. So it can be seen like a isolated grid, although there is connection to the national grid. And so we are just posing an extra system there that could bring an extra service to the local grid and see what's the synergy between this hydrogen system and the local grid. So they have a total PV capacity of about 86 kilowatt peak already that are planned to extend. So the tender is finished, and so should be smooth and nice, this one. In terms of challenge and next steps, I already mentioned a few during my talk. So we had the first one, we had the bankruptcy of Fusion Fuel, so they got bankrupted on the meanwhile. So we had to replace them by a new producer in Sines, because then it's not just by a hydrogen producer in Portugal, it has to be in the location where it was planned initially to make it work. Fortunately, there was a company interested on this, it's Wind Power. They are the ones responsible for the 10 megawatt implementation, but as I already mentioned, we are pending on the national decision for this budget to come. So there were other projects that were attached to this H2 talent where the budget was like from elsewhere, such as the backbone developed in Évora, which never happened, which led us also to try to work on a different solution, such as the local blending of the system, which then poses extra issues regarding legislation. So it's not only one way, there is one after the other. So on the way, we face several issues that we are kind of managing as we go. So as I said, local legislation do not cover hydrogen in public areas, so we have an issue there. And wind power plant, they don't have also a two-trailer filler to link all the assets yet, so we have to look for complementary funding to cover this. Priorities for first half of next year. So it's progress on this commissioning for the H2 production. It's critical here. It's a pillar of the project. It's also we need also to progress on the H2 applications. As I told you, one of the vehicle tender is already starting, and the Collateral Island asset is also on its way. But then we have also the pool blending infrastructure that we are also working on to get extra budget to complement this, because as you can understand, if we have a blending system that is ready and it is like supplied to the main meter, a gas meter of the pool, it's fine. There is no extra infrastructure needed. So it will be a bit more on the water heating system, but in this case now it's different. So we are not worried about the water heating system anymore. We are working with the infrastructure that is kind of replacing the initial, let's say, idea. Then the installation in Culatra, it's ongoing, and we also wanted to expand the Hydrogen Academy, because we are a bit ahead of local legislation. This is also a good vehicle for the authorities to learn a little bit with us, and we are also working on safety planning and risk assessment, which brings a lot of valuable information to the project. And from my side, I think it's all. Thank you for your attention.
It was very interesting to know more about this project. Maybe we have some comments or yes, please.
I have a question. You mentioned that you're going to apply also a fuel cell bus. Have you already done it or not?
Yeah, we are on the process of tendering. So it's a public tender, and we have started the public tender. So we are
For the legislation, the move of the bus that is carrying hydrogen does not create a problem.
Yeah, so it's I see you are talking about the safety regarding the circulation of the vehicle. As of that, we are not very much worried with this situation because we believe it's a certified bus. The refueling station is certified as well, so it was posed into different let's say situations, and we never have heard about issues with the fuel cell bus from at least the suppliers we are in touch with, and also for the PRF refueling station. So we are not very worried about that from the technical point of view, although I understand the concern because if there is a car crash or something, we may have some issues.
Yeah, but I mean, if there is an issue with the legislation with the use of hydrogen in public spaces, the bus obviously is a kind of
With that we are
danger.
it could be dangerous, but we rely on the technology, and it's more controlled than an environment like the pool where we have hundreds of people going around without knowing that there is eventually potential explosive area there.
I'm not arguing against you, but obviously the bus as well. I mean, if it moves through, public spaces, it's the same danger. And
yeah, could be. Yeah.
Hydrogen buses are circulating all over Europe currently.
Yeah, but I think it's a more validated situation, I believe.
Thank you.
Thank you.
Thank you. Do we have any other questions?
Maybe some question about the technology. I just read that you went for alkaline. Was a decision made because of the partner or a technical or economic?
It was the partner deciding to go for that because they believe that the maturity of the technology will fit better their purpose. They will start with green PPAs, but they will eventually move to PV afterwards, but which could not have a best fit ever, but they decided to go for a more reliable technology and let's say mature system.
But then you are not connected to the grid at all, or still?
We are connected to the grid.
So both renewable and
Exactly.
grid as well.
Yeah.
Great. Thank you so much.
Thank you.
I welcome now the next speaker, Soren Kat-Stenix, who will present the Conway project, creating and enabling hydrogen valleys at ports.
Yep. So thank you all for coming. My name is Soren. I work as a technical project manager at Hydrogen Valley in Denmark. I might start off with a little disclosure, not to sound too, doom and gloom, but we're facing some issues in our project, and that represents my presentation as well. So bear in mind that I am still pro-hydrogen, but we are facing some issues, and I want to address them through this presentation. So to start off, the scope of the project is to create green hydrogen from renewable sources at the port of fuel cells. We want to decarbonize the port's operation, develop refueling stations in the local area, integrate the local industry in the hydrogen valley, test and validate the business case of how the business case is affected if we are to utilize both the excess oxygen and heat. So, and at least the last part is one of the most important parts of our project, I would say. So, regarding the key milestones of the project or the timeline, we started back in March 2024. So we've been going on from a year and a half, just like H2 Talent. And we are working on the system design at the moment. We've been pushing this timeline a bit forward because we have some issues, not regarding the system design, but more in regards to the business case in this sense. And also that is due to the way the application has been written and the grant has been permitted. That faces some problems for us now. But we are still confident that we will secure the operation of the system, that we will start the construction by 2026, and that we will secure the 2-year pilot period that we are obliged for. So regarding the hydrogen production of the project, that is done by Norwegian Hydrogen. They're also the key partner in the project. They are the one coming with the external finance for the project, and we're looking at a capacity around 5 to 6 megawatt for the electrolyzer, and we expect at least 500 tons of production as well per year. Regarding off-takers, we have 2 different hubs. One of them is the mobility. So we have a joint part consortium by Renewable Spedition, Transport Center, and Milan, where Renewable Spedition is a local logistics firm. So they will be owning and operating a few hydrogen fuel cell trucks. And Milan will build and operate the refueling station at Transport Center. So that's the reason we have this 3-part joint venture. The oxygen of from the production will go to Honest, and Honest is a land-based agriculture. They are agriculturing trout, so we will have a direct pipeline from the electrolyzer up to this land-based fish farm, and they will also be one of the off-takers of the excess heat. So a 2-part, very crucial part of the project. And also one of the tricky parts of the project is the development of different industries at the same point of time. Biomega is the second off-taker of the hydrogen. They will have a direct pipeline from the electrolyzer into their burners. So we will substitute natural gas for hydrogen. Obviously, they use it for steam production in their processing of cut-offs of the fish. So they are making fish oils and proteins. So quite a versatile company, but they of course has a specialized system for this. So regarding the ecosystem, it's fairly simple, to be frank. We are compared to the H2 Talent. We have a rather small ecosystem. We have a local energy supply at the port of Hirtshals, which is already established, so we'll connect to an existing infrastructure. So we'll be creating this part. So we are creating the energy management system, the data monitoring, and setting up the electrolyzer. And then we're securing the infrastructure needed for distributing the different products. And this is what we send in for the grant application. So here you can see the different partners. There'll be a better overview later on. It's a bit chaotic, I know, but it shows pretty well how the consortium works with the renewable energy located at the port of Hirtshals and owned by the port of Hirtshals. Goes into the electrolyzer, and everything kind of goes on from there, and we utilize all byproducts from the electrolyzer, and that is the key point of this project. Our role as Hydrogen Valley, we are kind of the dotted line around it all. We are in charge of the replication strategy. So what that means is that we look over the shoulders of everyone in the consortium, assess what they're doing, evaluating it, and then we are to make a guidelines for future hydrogen valleys, especially those based around ports, assessing also which port might be natural locations for hydrogen valleys in the future, and which are not. We haven't seen any at the moment, but we are assessing that. And we're also making a template for what are the checkpoints you are to assess when you are developing these hydrogen valleys, and naturally, as a starting point, that you are a port from our perspective. So this is the actual valley, or picture of the valley. Just for reference, this is about 3 kilometers long from Hirtshals Transport Center down to the port. And as you can see, currently there are, you can't see the last one, but there are 4 wind turbines located at the port of Hirtshals. Will be connected to 2 of them by a direct line, but also connected to the grid. So the primary use of energy will come from the wind turbines, and then of course we'll buy certificates from the grid if that's necessary. Around 90% of the hydrogen will go to biomega, we estimate, and that's by pipeline. So of course we have a difference in price there. And that is one of the things that we are assessing as well. What are the benefits, cost, efficiency regarding transporting hydrogen by truck or by pipeline? Because the pipeline will only go, hydrogen pipeline will only go from the electrolyzer and onto the local industry by mega. The rest will be stored at tube trailers at the production site and then transported these 3 miles or 3 kilometers onto Hirtshals Transport Center, where it's repressured up to 900 bars for truckings. Yes. I mentioned the oxygen pipeline as well. That will go to Honest. Originally, when we made the application, they were to be located right here. And we thought it was a great idea to have a pipeline go there. Now they moved location, and we are obliged to make this infrastructure. So that poses some issues regarding the budget. But as I mentioned, they are to set up a brand new land-based agriculture right here. Right now it's a field, and they're looking at a budget that's about 10 to 15 times bigger than our hydrogen valley. So for them, they think it's peanuts. We think it's an issue for the project. We are kind of dealing with that. Regarding the heat, it is to connect to the local district heating network. All of Hirtshals is connected to the district heating. So that will be the offtake of the excess heat. In Denmark, district heating is very common in almost every city. So that is where we suppose all of the excess heat will go into. But as it is implemented already, the production of the heating for the houses is already in place, and that poses a different kind of problem as we are to take over some contracts that are already in place. We'll see how that goes, but it's an issue we foresee in the future. So regarding lessons learned from this project, as I mentioned, doom and gloom at the start. This is where we are entering it. We've made a few bullets that we see already. The reason that we're seeing them is that the FID of the project must be made in the 6 months of the project, where we should have made all the system engineering, but due to different problems regarding the business case, this has been postponed, and now we see some experience being made. I'll start by taking you through this graph. It shows the ability to influence the cost of the project versus the cost of change. So the cheapest point of time where you can make a change is in the beginning of the project. And even before the project is even more cheap. So when you make the application for a hydrogen valley, you really need to think it through, because you are obliged to come through with what you write. one of our issues is that, or not an issue, but it's a challenge that we are obliged to deliver this oxygen. It narrows down the technology we can choose from regarding electrolyzers. One of the things we didn't think of when we were to make this application. So there are a number of things that you might be able to look into, and some you'll have to go along with. But do your homework, prioritize your effort in the beginning of the project, even in the pre-project, the pre-studies, they are very, very valuable. Prioritize those. And in mapping of the location and the possibilities of the local area. Here, I'll say location is key. This is due to resilience of the valley. As I mentioned, we have 90% is estimated offtake to Biomega. But what if they go bankrupt? Where are we to do our 90% of the hydrogen? So this resilient thought, think it through and try to make a redundancy plan for your project. I know it's not always possible, you can't foresee everything, but this resilient thought is very important for these valleys. You are kind of making a closed loop system, and if you are dependent on a single thread, you're very vulnerable. Then I mentioned the structure of the consortium needs to be thought through. This is due to, say, the conflicting interest. We are a company who likes to share our knowledge with everyone, our experience. We are not profit, but there are companies like universities that are being paid by publish through papers. And if we are to give all of our knowledge beforehand, it makes no sense for them. So there might be an interesting conflict as something as cheap as knowledge. So it's not always only about the business case, it's also how about the collaboration of the internal consortium. It's very important. Then the last thing I've highlighted is try to work backwards and secure the right partners. So the meaning of this is that when you start a project, I would say start with someone who wants to produce your product and someone who wants to be the off-taker. The middle part will sort itself. But you need the same commitment from the off-takers as you do as from the producers. The producers, of course, want to sell a product, but if the off-taker is not as committed to the project as you are, they're easier to jump off or scare off. So start from both ends and have a very close eye on the off-takers. They are the key for the project. I think those were the dooming words. I don't know if I've scared anyone off, but do bear these in mind. I've seen you guys nodding as I've spoken, so I think I've at least mentioned some of the more important keynotes here. Yeah, here you can see the overview of the project partners. One of those I've mentioned a bit less is the ones like VTT and Opura. They are in charge of the energy management system and the system operation, so the EMS. Yeah. Thank you, guys.
Thank you very much. It was very interesting, especially appreciate the last slide about lessons learned. And I'm sure that this could be aspiring for the other projects in other countries. And maybe we will have time to talk more later. But in the meantime, maybe we have a question, comment, feedback.
Since you mentioned the importance of the location, did you have any trouble in finding the location, or was the process smooth?
Yeah, so regarding the location of this project, is that we were actually invited to this project by Norwegian Hydrogen. So they had already set the location. And I assume the reason for they chose this location was there was already an established renewable energy source there at a port. They're kind of engaged in the marine sector as well. So there are two check marks made by them. I assume this is my own thoughts. I stand by them, but it's not confirmed. I know they made a few assessments regarding different locations. But in Denmark, generally, this is located on the west coast, which is where we have our renewable sources, and a lot of ports are located on the east coast as well. So I think that's the main reason. Denmark and Norway have a kind of strong collaboration through that port as well might add to it. So I think that's the main reason. But we didn't have any direct participation in making or marking the location for the project.
Thank you.
I mean, just very quick question about the oxygen. Do you consider also further, I mean, is it needed some further conditioning or about purity?
We don't assume, and that's because it is to be injected directly to these tanks. So if it has some impurities, it would either be hydrogen or excess water. And we foresee that it bubbles off. And through the tech specs that we've seen from the electrolyzers we are assessing from, we are looking at the 99% oxygen purity. So it's very high quality oxygen. Anyway, it's not medical degree. We've looked into that as well, but the agricultural company, they don't foresee a problem with this.
Yeah, because usually it's a typical oxygen off-taker are a hospital, for example, and then you have to add some processes.
Exactly.
Okay.
We hope that we can inject it directly and we don't see any problems with that.
Thanks.
Thank you.
Definitely.
Thank you. So now,
That was, if there were any extra questions, I will.
here. So next speaker, Patrick Witte, who will present Laxaival, development of a full value chain hydrogen valley in Luxembourg. Please, the floor is yours.
Yeah, thanks. So I'm Patrick from GPSS from Luxembourg. Thanks for having me. I'll be presenting the Laxaival project, and this presentation will be a bit shorter. So let me see one direction. So Laxaival. What is Laxaival? Laxaival is a flagship hydrogen valley project in Luxembourg because it is the first project of its kind in Luxembourg, in contradiction to the two projects which were already presented. In Luxembourg, we have no hydrogen infrastructure at all. Nothing. The only thing we have is we have one company which is consuming hydrogen right now, dry hydrogen. That's it. Luxembourg is not known for its strong renewable energy sources like countries in Scandinavia are, or that there's any bigger gas or petrochemical industry like it is in Portugal. So we are starting really at zero. And in this case, valley means really creation of a valley, creation from zero. And we're really targeting the whole value chain from the production to the end use. In this case, industry and mobility as the end users. And we have a consortium, also a very big consortium covering everything from university industry, the mobility providers as the end users, and also research institutes. Once again, this is really unintuitive. So we have the, I would say, more or less typical topics for more or less every hydrogen valley, which is everything from the beginning, market assessment, uptake, then engineering, production, storage, sector coupling, up to the end users, and also on top of this, stuff like digital twins, which are also very present at this conference, but also stuff like perception, LCA, and for this project, a bit special already, the replicability is a very strong point, to the extent that we have partners from Ukraine and the Czech Republic already as part of the consortium from the beginning, to have them really deep in the project to transform the knowledge out of the project to their respective projects in the future as soon and as smooth as possible. We have, like I said, we have 17 partners. Most of them are from Luxembourg, but we also have partners from Germany, from France as the neighboring countries, but spread across Europe. But the main partners naturally are from Luxembourg, and every partner has its own focus in terms of the work packages, as it should be in a project like this. And we have the different work packages. I don't need to go too much into detail in this because yeah, like I said already multiple times, it is a very classical structure for a valley like this, with the one difference that we are really covering the whole value chain. Most values already built up on something which is already present, or have partners which are already in the topic or in different parts of the topics, and we are really starting from zero in every work package we have here. There is in Luxembourg, I don't know how many of you know Luxembourg, but Luxembourg is in the end, I would say, the smallest real country in the European Union. So it's not a microstate, it's a real country, even though it is relatively very small, with just around 500,000 inhabitants. There is a hydrogen strategy already present, which aligns with the EU strategy. So this project is also in line with this, and that's also the reason why this project, as it is intended for the green hydrogen undertaking, is a project which is funded on one side by the green hydrogen undertaking, but also on a national level. We are aiming for a production of 500 tons of hydrogen per year. In comparison with other projects, that's not that big, but it would be enough to satisfy the 100% of the need of hydrogen which is present in Luxembourg right now. So it is really a significant amount, which will be split up for like more or less 2/3 of it are going to the industry, which is already consuming hydrogen, and 1/3 to mobility, which is a new sector. At least hydrogen mobility is a new sector which will develop inside of this project. Oh, it's wrong direction again.
Yes,
So we already started the project at the very end of 2023. So it's already ongoing for more or less 2 years, and it has a split budget from the hydrogen joint undertaking and national funding. But we are at a point where the project, more or less, it's not at a complete or at a full stop, but we are very much delayed by the situation, which is that we don't have a final investment decision yet. But there's a very good reason for this, because if you take a closer look, and that's also what makes this valley probably a bit special from other valleys, is if you take a closer look, who are the most, or like the key participants of the whole project. And in this case, if we're talking about production, we have two consortium members who are in the lead for this. And those two are the Innovos or Ensevo Group, which is Luxembourg's biggest energy company. It's probably more or less the only energy company in Luxembourg, but it's the biggest one. So it's not just a small energy company which is really interested and sees a possibility to get some additional market share by being the first ones active in the hydrogen sector, but it's the biggest energy company in Luxembourg. And on the other hand, we have forbroader, which is a Luxembourgish company, but it's known globally for building most of the times iron and steel industry. So they are really a global player and will be a global player also in the hydrogen production, especially if we're talking about alkaline hydrogen production, because this develops around the iron and steel industry. So there we have two companies who are really the big dogs in the country. And the same goes for, if you take a look who's the end consumer in public transport, we have someone like Sales Lenz, which is the second biggest public transport company in Luxembourg. Luxembourg is a bit special because public transport is free. So everything is via tender. Every bus route is via tender. So once again, we have someone here who is not there to gain additional market share by being the first ones in the hydrogen sector, but someone who is already well established, but also here to be part of this first hydrogen, of Luxembourg's first hydrogen valley. And same goes for the industrial application. Like I said, we have one off-taker of hydrogen in Luxembourg right now, which is the Ceratizid Group. Once again, it is a global player from a very small country. I think there's a very fun statistics. I think one of the main businesses is like the little balls in the pencils. in the tip of the pens. I think 95% of all of these boards come from this company. So once again, global player. They don't need to gain additional market share inside of Luxembourg. They are already the biggest company in the sector from the beginning. And then we have Guardian, who's a glass producer, who are not using hydrogen yet, but are planning to use hydrogen in the future. Also, Guardian also is a very big international company who are present in Luxembourg. And that was more or less the roundup of it. And as you may have noticed, there was not so much detail about the technical implementation because, like I said, we are still in the phase pre-FID. And we are in the phase of pre-FID because, and I wanted to emphasize it a bit, this is not a project of companies who are very enthusiastic in the topic of hydrogen or companies who need to differentiate themselves from other companies because they are the first ones using hydrogen. This is really a grown-up valley with grown-up companies taking part there who need a very, very robust business case in order to get the decision to invest in something like this. So in the end, what we have is a valley which has the chance, if it materializes, to be a very, very grown-up hydrogen valley right from the beginning, starting with the challenge and also at the same time the chance to start from zero to develop the whole hydrogen value chain in a small country, which is small but has a lot of opportunities for innovations like this.
So actually we work together in this project, but I take care of the social acceptance perception. And I can say that in this project is a big part of the project, and I'm very happy to know more about how it will go in Luxembourg. And it's nice because it's quite new project, but I'm sure that there will be a great future. Maybe we have some questions from the audience.
No, that's a good sign.
So everything was clear and perfect. So let's move on. Elena, prego. So actually, she will present today the TRIRES project accelerating the local energy transitions through blended HU financing. Please.
Good afternoon. Thank you very much for your invitation. I'm Elena Koustibi, and I represent the European Affairs Department of Motor Oil Group and also the TRIRES coordination team. Before talking about TRIRES, I would like to say a few words about our company, Motor Oil, in order to understand better the importance of hydrogen initiatives for paving our future sustainability and resilience. Motor Oil Group is evolving beyond traditional refining into a multi-energy leader, integrating renewables, hydrogen, and circular economy solutions. Our investments are positioning us as a key player in Greece's and Europe's energy transition. We are implementing one of the largest energy transition programs by 2030 in the region of Southeast Europe, worth 4 billion euros with 3 strategic pillars: fuels, electrification, and circular economy. Regarding hydrogen, it is an increasing priority for us. We are strongly committed to advancing the hydrogen economy, and we do this through these strategic investments, solid partnerships, and participation in EU-supported projects. And my presentation today will highlight how our key project TRIRES, funded by the Clean Hydrogen Partnership, can act as a model for developing hydrogen ecosystem at the local and regional level. The TRIRES Hydrogen Valley is Greece's pioneering small-scale hydrogen ecosystem, starting from our refinery in Agioi Theodori in Corinth and spanning across Attica and Peloponnese region, with the potential for expansion towards the Balkans, Southeastern Europe, and Mediterranean. It is implemented under the Horizon Europe Clean Hydrogen Partnership with 26 committed partners across 5 countries, achieving important knowledge exchange between pioneering and emerging regions with supplementary expertise stemming from industrial, academic, private, and public institutions. It is a 5-year project with an 8 million euros grant. Treaties represent a milestone in the country's energy transition by integrating renewable hydrogen into various pilot applications in industry, transport, and energy sectors. 2.4 tons of green hydrogen produced through the FIRA project will support this application with significant CO2 savings. In industry, hydrogen will decarbonize MOI's refinery and LPC lubricants refinery, replacing fossil-based hydrogen. For mobility, we are deploying hydrogen-powered buses, light-duty vehicles, and the fuel cell ferry for maritime transport. In energy, a small-scale hydrogen fuel cell unit at Piraeus Port will demonstrate clean power generation. In addition, various desktop studies will be conducted in existing and future applications of hydrogen. Now, this slide shows the entire value chain of hydrogen, summarizing the innovation developed within the FIRA project that is also co-funded by Clean Hydrogen Partnership and coordinated by Motor Oil, upscaled by RRF funds, and how this production side is linked to the sister project theories on supply and end use. In addition, the Valley forces the development of a digital twin to simulate valley operations, the creation of business models for application and scalability, and engagement with national authorities to enhance and harmonize the regulatory framework in line with European standards. Okay, regarding infrastructure development update, we have secured funding for the FIRA project, initially 30 megawatt, now being upscaled to 50 megawatt with additional works supported by Greece's RRF under the Green Hydrogen project. The 50 megawatt alkaline electrolyzer has reached a positive FID and detailed engineering and construction are underway. Our first hydrogen refueling station is now operational at the Avin station in Agioi Theodori, co-funded by the Safe Transport, and the second hydrogen refueling station is being prepared for tendering at the public bus depot in Attica for OC. Feasibility studies are ongoing for a hydrogen-powered ferry, a hydrogen pipeline to Fulgor, and hydrogen use in lubricant production at LPC. For logistics, 4 hydrogen tube trailers have been acquired, and a report on virtual pipeline on scheduling and hydrogen distribution optimization. In mobility, we are procuring 1 light-duty vehicle for municipality of Loutraki, preparing tenders for 3 fuel cell buses for OC, conducting market research for a heavy-duty vehicle for Olbia Odos, and studying a maritime vessel retrofit with a shipping company. Our work in energy and industry pilots is advancing steadily. Tender documents are being prepared for 100 kilowatt fuel cell unit at the port of Piraeus, while the conversion of the LPC lubricants factory is progressing with the permit already submitted to the Greek ministry. On the regulatory front, we are closely following the new hydrogen supply framework under national law and recently adopted a licensing regime for renewable hydrogen plants. In R&D, we are developing a digital twin and continuing our scientific publications. The safety and supply dimension is also well underway with a preliminary safety framework for the Corinth Hydrogen Valley and HAZOP studies completed for the electrolyzer tube trailers and the first hydrogen refueling station. We are strengthening collaboration and knowledge sharing through participations in international forums, study visits to leading hydrogen valleys, and events like the June 2024 regional workshop on hydrogen innovation. And also we co-organized the third Jive Roadshow across Greece and the Balkans, gaining valuable skills in hydrogen mobility and safety. Finally, in outreach and communication, our project website and social media channels are actively sharing our progress. And we are very proud that IRIS received the Clean Hydrogen Partnerships European Hydrogen Value of the Year 2024 award. While the hydrogen sector is advancing, we still face several challenges. Many technologies and markets remain immature, and we lack coherent national strategies and incentives for off-takers, not just producers. In addition, permitting and regulatory delays persist while public awareness and safety perception still need improvement. We also need a stronger PPA mechanism for effectively link renewables with electrolyzers. At the same time, there are great opportunities ahead. Hydrogen can strengthen our energy independence and drive regional collaboration, positioning us as a key hub connecting Europe, Middle East, and North Africa. It can open new markets and value chains, create high quality and jobs and skills, and foster new, more sustainable productivity models. Regarding the hydrogen deployment timeline of the next years, we may highlight the following points. In 2026, procurement of hydrogen-powered vehicles and free fuel cell buses of fossil. In 2027, the electrolyzer will be in operation, demonstration of the power fuel cell unit in Piraeus port, and vessel with fuel cell for short distances. Beyond 2027, valorization of secured budget by the Greek Ministry for additional fuel cell bus procurement by OSI, while more hydrogen refueling stations will be under planning. Through the project implementation, we will continuously share information and engaging with pioneers, all players across the hydrogen value chain and the general public to raise awareness and promote knowledge exchange. And other expansion activities will be also designed. Thank you very much.
Thank you. Thank you so much. Do we have any questions here? Comments? No. Okay. Thank you so much. So we continue with the next speaker, Philip Fish, who will present EcoWave.
No, ignore this.
And this is the first project to receive the Innovation Fund in Luxembourg. Please.
Thank you very much. Also, warm welcome from my side. So I'm Philip Fish, CTO of GPSS, same company as Patrick, which already presented the Luxhyver project. And this is, as Mariangela said, EcoWave. So it's short form for energy community for hydrogen on-site production from wind and agrivoltaics for industry decarbonization. So I will stay with EcoWave, but you will see in the next minutes why this title is as it is and what are the elements of it. So as we are the first innovation fund funded project in Luxembourg, one important thing is that you have to have innovation within the project. And within EcoWave, there are actually 4 pillars which can be seen as very innovative for the green hydrogen production. First is, it's a first-of-a-kind project for green hydrogen production together with the Luxhyver project, because as Patrick emphasized already, there is no just less hydrogen infrastructure already built in Luxembourg, at least no production yet. So these 2 projects are really demonstrator projects, will already receive national funding to be that. So yeah, we are first of a kind. What differentiates EcoWave from Luxaival is the supply of this electricity for the hydrogen production, because Luxaival is more on PPA purchase of the green electricity, and we have really on-site direct coupled renewable energy sources which will feed the electrolyzer and produce the hydrogen. To use this electricity, we are planning to use it through an electrical sharing energy community on medium voltage level. This is also something new for Luxembourg, but also for the neighboring countries. In Luxembourg, yet there's just a legal basis for low voltage energy sharing. So this is also an additional innovative part. And last but not least, because we are directly connected to renewable energies, it's fluctuating supply of electricity, which means that the electrolyzer also sees this fluctuation. So we need to be prepared of it and develop an optimized control strategy so that the electrolyzer is not harmed too much and the lifetime of it gets too slow. So this is the last pillar, the development of such intelligent control. To give you an idea where we are, so you see Luxembourg as a country, and the planned area of the project is somewhere in the middle, so in the northwestern part of the capital, Luxembourg, on a small rural agricultural area. And this is also where we planned it. So we looked at different sites within Luxembourg, did feasibility studies, and decided to go there for multiple reasons. One is already existing and implemented infrastructure. You see on the top northern part of the fields, there is an already existing agrivoltaics plant. So agrivoltaic is the combination synergetically from PV solar production and agricultural land use. And this plant is already built by our company, by GPSS, and in operation since October last year. So within this, we already built a medium voltage line, which is connected to the public grid. See it here in the bottom. This is the connection to the public grid. And within EcoWave, this energy park will roll. So we will build an additional agri-PV plant in this kind of magenta colored surfaces, together with a hydrogen production of around 2,500 meters square in green. And in the back, you see a wind turbine, which will be built by our consortium partner, Solar, which is also a Luxembourgish company, which almost operates and controls every wind turbine in the country. So the electricity will come from this new wind turbine together with the agri-PV and shared for the hydrogen production directly on site. And you see by the facts and figures that this is really the core of the project itself, is that the directly produced electricity will be used and stored as green hydrogen via a PEM electrolyzer. So wind turbine will have an installed capacity of 4.3 megawatts. The agri-PV 2 megawatts, both will feed the electrolyzer, which will have 2.5 megawatts. So on just 15% will be surplus electricity, which will be injected to the grid. So it's not an isolated project. We have a grid connection, but we focus to rely on on-site renewable electricity. And this surplus electricity is planned to be shared within the municipality, also through this concept of an energy community. For the hydrogen, unfortunately, in the first phase, there will not be an off-taker on site. There is a bus operating company very close to it. They are also thinking of decarbonizing and purchasing hydrogen buses. So in the next phase, this will be an additional off-taker, which is directly come to the plant to fuel the buses. But in the first phase, it will be a transport of hydrogen. So we compress it on site, fill it into trailers, and sell it to a gas distributor who will deploy it to industry and mobility in Luxembourg and the greater region. The outcome of it will be from the on-site renewable energies, plus in the second phase, a ramp up via smaller portion of a PPA. So in the end, we are planning to produce around 2,900 tons of green hydrogen over 10 years of operation, which will then be used to decarbonize industry and mobility. you see that it will be roughly around 23,500 tons of CO2 emission, which could be avoided by substituting fossil fuels and gray hydrogen. It is completely in line with what the EU supports and what the aim is also from the national hydrogen strategy. So that's also why we receive from both sides the funding for the project. And it can cover up of more than 60% of the current hydrogen demand in Milan. The last pillar is what I already said or introduced, is this intelligent control. So renewable energy, as we all know, is not always available. And also for the hydrogen production, this is a challenge. So what we develop are algorithms and parts of it that can forecast what is available in a certain time frame, talking about the supply of electricity, but also what is the off-taker able to take off from the hydrogen. So is the logistics company already on the side? Is there an empty trailer available, or is my trailer almost full, so it does not make sense to run the electrolyzer at full capacity and shut it off very rapidly? So this is the forecasting part. And this is then used to implement an intelligent control based on model predictive controls. So digital twins, also here a very important topic of the complete project and installation components, so that we can decide what does make sense. I give you an example of this. So if we see it's summer, we're producing full PV power, 2 megawatts, electrolyzer is almost running at full load, and there is a field of clouds coming. You see that in the next 15 minutes, it will drop harshly. So we can optimize the strategy and smoothly turn down the supply to the electrolyzer to make it already prepared that there will be a drop in supply. But also we can start, because we have a little bit batteries also on site, to prepare it already that in the next 5 minutes there will be again an increase in supply. So to run it already, get it up, ramp up, so that we can produce as quickly as possible the hydrogen again. This all is done to reduce degradation and to increase efficiency during production, both resulting in reducing costs of the hydrogen production itself. So talking about the timeline, so what you see here, that is the timeline of the Innovation Fund project. Of course, before the GA signature and before the official start, we already did feasibility studies and pre-technical studies to set everything up. But then in August this year, the EcoWave project launched, and we are going to have the financial close by the beginning of next year. So we are currently applying also for all the permits and this stuff, and we are quite confident still that we can achieve this timeline. Then there will be a build-up phase, installation from 1.5 years, 18 months. This means that by Q3 2027, the whole plant, because the wind turbine will also be installed, agri-PV and hydrogen, so altogether will be commissioned and in operation by the beginning of 2027. And then there will follow 3 years of operation, which will also be monitored within the Innovation Fund project. And last but not least, I would like to show what such a local energy system can help and what the challenges were when we looked at the site. So we had discussions with the local DSO. DSOs are most of the time, I think, not so very dynamic and more traditional and conventional. And as they yet evaluate such a project, is they look, what grid capacity do I have still available? And the information they shared with us were 5 megawatts. So what did that mean? agri-PV1 already implemented. So even an additional wind turbine, we did not get permission to do that without the EcoWave project, because within that, we shared with them our simulations, our already gained results, and they see that the production profile of agri-PV and wind on this side were, speaking for itself, already very complementary. So you see that this 5 megawatt was not so often, the limit was not so often stressed. So even with the 2 megawatt again, so you see in total we are more than 8 megawatts installed to this connection point, and with the hydrogen production connected before the grid connection point, we showed that it really reduced the grid load and can even provide flexibility service to the DSO. And then they were very open to this discussion. They are not member of the project, but they are very supportive and see that it is feasible and very impactful also from the DSO side to have these kind of local energy communities where you produce the green hydrogen as a storage medium for renewable electricity. So, yeah.
Luxembourg is a small country, but a lot of projects are going on. And thank you for this clear overview. We don't have so much time left, but I would like to invite Pietro Caplo-Prisco. Sorry, if you want to give the closing remarks and maybe, what is the takeaway of takeaway home?
Yes. Well, I will be brief. I don't think that there is much to be added to the very good presentations. Just for a moment, I had the feeling it was the coordinators anonymous meeting group, like I am trying to implement a hydrogen project for 18 months, and it's not working. I'm sorry. Like, as I said, it's not all doom and gloom. Indeed, there are difficulties. There are not easy projects, but things are happening. I think that this is important. No, it will not probably be the valley that you imagined at the beginning, but you have put down a number of recommendations, each one of you. You are all operating in a different ecosystem, the desert of Luxembourg, then in Portugal, we already have a very rich use of hydrogen, and you're trying to plug in, then you're in the harbor, then EcoWave is bringing even new solutions that could be really useful for the valleys, I can see. And then we have also Greece. So indeed, there is a variety of valleys with a lot of difficulties, and you're not shy in highlighting all of them, but also a lot of opportunities. And I think when I look at, from our perspective of the joint undertaking, what I said earlier, we started in 2016, and all of that stuff was for lab, something for tomorrow. Now it's happening. It's happening on the ground. Yes, not at the speed rate that we were imagining, but you dropped some good ideas on how to overcome that, the careful engineering, be pretty sure of what you want to do, secure a solid architecture of your consortium, the beginning and the end, the production and the end users, and I would agree with that one. Things in the middle, you could agree that they will sort themselves out to a certain degree. But indeed, if you do not have the FID from the hydrogen production, which depends on the vehicles, which depends on the industry, which depends on the tenders and all that, that becomes very tricky. You need to anchor this valley on a couple of strong points and start to build around that one. And then think also about how you frame your valley. 90% of the demand with one player, yeah, it's great, it's safe. What if they go bust? What if they leave? So do you fragment the demand, distribute it across several end users? Safer, but kind of a challenge to manage, to synchronize. And then we have seen that also the FID, it doesn't depend only on the national additional funds that may or may not be available, but as you said, like there are motor oil, there are other very mature players. They need a very solid business plan, which maybe doesn't need support schemes, but they need like a TCO which is viable. So all in all, I think that's hope meets reality. That's the phase in which we are. But I'm pretty sure that when we meet again in 1 year, in 2 years from now, we will not need to sit all in a circle, depressed to highlight what are the challenges, but there will be also quite some good success in there. So thanks again for being honest up front, and good luck to any of you that are implementing of the valley, if any of you are thinking about valleys, don't get scared. Can be done. Can be done, and there are solutions. All right.
Thank you. Perfect in time. Thank you to the speakers. Thank you everyone for your questions. And get in touch. So take your business card, exchange, talk, and enjoy the rest of the conference. Thank you.
Thank you.